Hi calculus students. So today in class we learned how to estimate with finite sums. And what we were learning to estimate was the area under the curve. So given any type of function, so in the first example we had a straight line constant function. In the second example we had a parabolic function. But given any type of function, we can estimate the area under the curve using a finite number of rectangles. So this means we find the area of the rectangles and add them all together to estimate the area underneath it. So the three methods that we learned about were the left-hand rectangular approximation, where you use the left corner of the rectangle and align it with the curve. Here we got 5.75 feet. We learned about right-hand rectangular approximation, where you use the right-hand corner to make rectangles and approximate the area. Here we got 7.75 feet, which is a lot higher than the previous one. And then we also used midpoint approximation, where instead of using the corners, you use the point right in the middle of the top of the rectangle, and that is how you create the basis for the height, by lining that with the curve. And midpoint approximation method is the most accurate one. So here you can see the approximation was right in the middle and was very close to the actual area that the calculator calculated for us. So now we're going to proceed to some more examples. Let's start with example 2. Given f of x equals 5x squared minus cosine of x on the interval between 2 and 6. Part A asks us to sketch the graph in the appropriate window. It's always going to be a good idea to know how to sketch this, because you are likely going to want to reference the sketch to know what your rectangles look like. So this graph, I graphed it on the calculator, and it really just needs to get the general shape of the curve. For instance, is it increasing or decreasing, or concave up and concave down? The increasing and decreasing and concavity are important aspects to get, but it doesn't have to be perfect. So between 2 and 6, this graph starts low, increases, and is concave up. So I'm just going to draw it increasing and concave up. So what we are actually trying to take the area of would be this yellow section here. We're trying to find the area of this part right there, from 2 to 6. I also will label this as f of x, like that. Okay. So, part B says, consider the region bounded by f of x and the x-axis. So that's saying the region under the curve and between the x-axis, which is indeed this area here. Use the left, right, and midpoint rule with 4 rectangles of equal width. Let's start with the left. Actually, in my examples, I start with the right. So I guess let's start with the right. I'll just label it R4. So this is my right. I'll start with a sketch. So my sketch is going to use, my sketches are all going to use this as the foundation. So 2, 1, 2, 3, 4, 5, and 6. Start low, increase, concave up. So when I draw my rectangles, if I'm drawing my right rectangles, when I draw my rectangle between 2 and 3, I want to make sure that the right corner will represent my height. So I'll use my purple marker to kind of label where all the right corners are going to be. So I'm using the right point. So this right point there, this right point there, and this right point all the way up. And then I use that as the height. I go over and down, over and down, over and down, over and down. Not perfect, but it works. And we can see from this that my graph is going to be in my value that I get, my area value, is going to be an over approximation because I see that my rectangles are all over the curve. So I'll know that this will be on the high side. Okay. I made 4 rectangles of equal width. And so you can probably tell from this picture that the change in x that I need for the widths of all my rectangles is just going to be 1. I do want to take note that you can always calculate the change in x by taking the interval. So here the interval goes from a to b, right? That's how you can think of your intervals. The change in x can be the interval length, so the length of the interval is b minus a, divided by the number of rectangles. Divided by the number of rectangles. So in this case, it would be 6 minus 2 divided by 4, which is 4 divided by 4, which indeed equals 1. So we could tell that equals 1, but sometimes it's not always going to be 1, and you can always use this method to figure out what your change in x is if you're having a hard time visualizing that. So our change in x is indeed just 1 in this case. So in my t-table, x and f of x, the values that I want to plug in for my heights are where I put my points. So I'm not going to use 2, I'm going to use 3, 4, 5, and 6. Three, 4, 5, and 6. These are my rightmost points. When I plug those into the equation, I get 45.99, 80.65, 124.716, and 179.04. Remember, these represent the various heights. So if you need help remembering, you could say, okay, this height is f of 6, which equals 179.04. This is a height. Okay. So to calculate my area, my RAM is going to equal my change in x, my change in x, which is 1, times the sum of all my heights, so the width times all my sums, which my heights are right here. So 45.99 plus 80.65 plus 124.716 plus 179.04. Eeps, that went long. Add them all together, and you get 430.3998. And this, as I said before, is an overestimation of the area. Okay. I'd like you right now to pause the video and try to find your left and your midpoint rules on your own. So try to find the left and the midpoint rules on your own. Pause. Okay, you found them, right? So here are the solutions for the left and the midpoint. I'll zoom out a little. Ugh. There's all of them all in one spot. So, like I said, the right hand was an overestimation, left because my boxes are all under the curve. This is an underestimation. You can see these are quite different. And then my M4, my midpoints. Midpoints, it's harder to see, but you can see that there's some spaces that are above the curve and then extra spaces that are below. So some above, some below. And so this is the closest estimation. There. Okay. All right, let's turn the page. We're going to do one more. This is, oops, that's the solutions. This is a table, and on the AP test, they like to do questions with tables and ask you to find the RRAM with a table instead of an equation. So before we had an equation and could make a graph, this thing, you could sketch a graph from this, but remember when you have tables and it's missing values, there could be weird things happening between these values that we don't really know about. So sketching a graph isn't the most useful in this case. So I'll show you the best strategy for figuring this out. So the table shows the velocity of a car as it travels for 10 seconds. This should be not seconds, this should be hours. And I know that because look at my table, it says hours. So 10 hours. Estimate the distance traveled by using a left hand and a right hand method. So in my table, I see that it gives me random time. So like 0, 3, 4, 6, 7, 9, 10. My x values are jumping all over the place. And remember that the x values represent the width of your rectangles. So what this means, the implication of this, is that the change in x are different for each of these. So we have to be a little careful because the change in x is going to be different. So let's make a little note of that. The time intervals aren't equal. The time intervals aren't equal. So the change in x is changing. So your change in x will be different. And I'm actually going to add a little column up here for the change in x. Okay? And the change in x will happen between 2 points. So between 0 and 3, x changed by 3. And you'll see why I'm making this little arrow type of thing. Between 3 and 4, x changed by 1. Between 4 and 6, it's 2. Go ahead of me. Okay. So here are my change in x's. If I were to graph this, I would label 0, 3, 4, 6, 7, 9, 10 on the x-axis, and then I'd have like a width of 3, a width of 1, a width of 2, a width of 1, 2, and 1. Okay. And then here is the velocity. This is my outputs. So if time is my input, and I got the change in x, which is the width, velocity is the output. And this is going to be in miles per hour. And just a reminder, this is representing the height of your rectangle. This represents the height of your rectangle. Okay. So let's start with my left hand. When I use left hand, usually on the rectangle, that means you choose the upper left hand corner. In this case, it means you're going to choose like between this two, like where the base is 3, the width is 3. It means you're going to choose the height on the left. And then where the base is 1, choose the height on the left. When the base is 2, choose the height on the left. So that's why this little arrow is kind of important, because it can distinguish, okay, here's your left height, here's your right height for the rectangle that has this width. So my LRAM, remember it equals the change in x times the height. So for the first rectangle, the change in x is 3, and then the height is 0. For my second rectangle, the change in x is 1, and then my height is 10. Third rectangle, the change in x is 2, and the height is 11. The fourth rectangle has a width of 1 and a height of 14. The fifth rectangle has a change in x of 2 and a height of 14. And then the sixth and last rectangle has a change in x of 1 and a height of 15. Okay. So you notice we have 1, 2, 3, 4, 5, 6 rectangles, even though we have 7 points. Basically, when you have 7 points, you're going to have one less rectangle. It's the same as over here. Like here, we went from 0 to 4. 1, 2, 3, 4, 5 points with 4 rectangles. So that's the way that it always works. Because you have like the points on the end, and you're always not using one point. So in this case, with the left hand, we didn't use this point of 18. We didn't use that one because it was on the right, the very last one on the right. So you add this up and you get 89 miles. Okay. Please pause me and on your own try to find the right hand estimate. Hit pause, try to find the right hand estimate. Okay. Assuming you pause, this would be the solution for that right hand. So now you'd use all the right points, the points on the right. Oh wait, I made a mistake. Oops. I think that I forgot the first one, I noticed, because I didn't have enough. So you should have started with 3 times 10, then plus 1 times 11, then 2 times 14, and 1 times 14. There. Now this is correct, so I need to add 30 to this. So this should have been 102 miles. Let me know if this is still wrong. I just looked at it real quick and the bell's gonna ring. But I think that's right. I think I just forgot that one. 1, 2, 3, 4, 5, 6. Yeah. Okay. I'll see you in class tomorrow. Bye.